This is chapter 18, question 105. You are given a reaction scheme and they ask which process is involved at some stage in this reaction sequence. There are three steps. Okay, this one, step number one, step number two, step number three. So we are going to look at each step and try to identify what is the reaction involved in every single step. Now the first one, we have alcohol turning into aldehyde. Now this is something that you know, okay, it is actually an oxidation. Although they use something that you're not very familiar with, okay, they use a copper catalyst, but they give you some clue, okay, -2 hydrogen. Remove of hydrogen or adding oxygen will be oxidation reaction. So I'll skip the second step and go to the third step because third step is the same thing. We have -2H. And you see, alcohol actually became double bond O. So remove hydrogen. Okay, so this is also oxidation. A, B, C, D, we do not have oxidation, but reduction, okay, no reduction here yet. Now let's look at the second reaction. We have aldehyde to alcohol. Okay. So actually this alcohol has been added into this aldehyde. Now let's draw the structure. CH3. I would like to show the display formula. Sometimes showing display formula is easier for us to see the reaction. C double bond O and H. Now at the end, what do we get is CH. Okay. CH3 is still the same. The left hand side CH3 is still the same. But the C double bond O, okay, is no longer there. And what do we have is the O became OH. Okay, the H is still here. Then it's bonded to O, CH2 and CH3. So this reaction, okay, is actually aldehyde added this whole thing. You might find this reaction very strange. You're not familiar with it, but actually it is very similar to the reaction between carbonyl compounds with HCN. Now let me draw another equation to show you how similar they are. I use the same aldehyde. Okay, but this time I change the nucleophile to HCN. Okay, at the end what you get is the CH3, the R group always remains the same, but the O became OH. The H is still there, and one more group is added to the C. In this case will be CN. So you see CN here. Then after that you have hydrogen added to the O. So in this case also the same. Hydrogen added to O actually came from here. Then, okay, H come here, right? Then you see the remaining group, okay, is now bonded to the C. The remaining group bonded to the C. So we call this type of reaction nucleophilic addition. Why nucleophilic? Because this carbon is partial positive. this is actually a nucleophile that is attacking the partial positive carbon. This is a partial positive carbon, so this is a nucleophile. That is why nucleophilic reaction. Now, two reactants are added together, you get only one product. So this is nucleophilic addition. So the answer for this question before that, yeah. Okay. So this reaction is nucleophilic addition. So let's look at all the answer. Which process is involved at some stage in this reaction sequence? Any electrophilic addition? No. Nucleophilic addition? Yes. Okay, I need to erase this. Any nucleophilic substitution? No. Any reduction? This is oxidation, this is oxidation, this is nucleophilic addition. Also no. So the answer is B.